So if we continue with section 6.4, it says the equation of change df over dx is equal to rf. This is different from our first equation of change. That was just a number, that was just a line because it was a linear function. Here, our rate of change is changing as the function changes. That's kind of a tongue twister. But it says where r is a constant, it says that f has a constant percentage rate of change. So it doesn't have a constant rate of change, it has a constant percentage rate of change. So long story short, that means it's an exponential function. So if your equation of change looks like this, then that means your function itself looks like either this or this. So kind of our goal on all these questions, you have your equation, and behind every equation there is an equation of change. Now the two different forms of the equation here, we have the e to the r and the e to the r here. In the first one, you're just leaving it as e to the r. Here, you're taking e to the r and actually finding out what the decimal approximation is. So we'll talk a little bit more about that when we get to a problem dealing with it. So let's look at number 9. It says the debt D in dollars as a function of time t in months of a certain company is given by this function. Write the equation of change for the debt of this company. So my equation of change, because it's in this form, again, my equation of change is of this form, RF. And they're giving us the function in this form. So I need to figure out what R is here so that I can put it here in the equation of change. Again, there's always two equations going on here. You have your normal equation and behind the scenes your equation of change. So this is just going to be dd over dt is equal to, and I'm taking the r value in this case, which is up here, and that's going to be negative 0.06 d. And that'll be our answer. If we look at 10, it says if f satisfies the equation of change, df over dx is equal to 8f, then f is an exponential function, and hence can be written as f is equal to a e to the ct. Find the value of c. So they're kind of using their own letters here, because you can use whatever variables you want. But really what they're asking, and they're kind of asking in a roundabout way, if we have just df over dx is equal to rf. So that's our normal equation of change. That's normally what the letters they use. And then if we change it to f is equal to p e to the rx, this was our normal function form. So the value here, r is this value. So here, because 8 is here, I'm just comparing it to what would the variable be in this case, which is c. So c is just 8. So it's kind of a confusing question because they're using the same forms, but they're using different letters. I guess they're just trying to trip us up. But it's really just going to be 8.